how to design slabs. Guys, I'm so sorry I didn't upload the whole module. I will do it. I will finish it by today evening or tomorrow. So I just uploaded only small part. By the way, today our topic will be about design of slabs. Just to remind you, our progress until this moment, we have concrete structure, because this course is talking about concrete construction. We have different parts in this building. Until this moment, we covered only beams. And we covered beam under the effect of bending moment. If you have bending, we can figure out how much is shear reinforcement. We covered beams under the effect of shear or torsion. And we can figure out how many or what is the spacing or how we can design stirrups to support beams against shear or torsion. Today, we will cover, or we will start to cover slabs. Slab. This slab we will be covered this week. And then next week, we will go through columns. And then finally, your foundation, which is footing. Before starting, I would like to give you an introduction. We have two types of slab. And I believe probably you learned this stuff before in structure analysis and the design course. One-way slab, that means you have slab. If you stand here on this slab, the only way for your load to go to support, only one way, this direction. Because the only support supporting your slab is this wall and that wall. Doesn't make any sense that your load will move or will go through this way or this way. Doesn't make any sense because we don't have any support for the slab at this location. This is the first case if we have something called one-way slab. One-way means this direction only. It's only one way, one direction only. We have another case. Sometimes we have a support here, probably. We have another support here, but the load still move only in one way. How? If the ratio between the longer span to the shorter span, longer span L, shorter span B, is equal or greater than 2. Let me explain it here. If you have plan looks like this. We have beam on this side. We have another beam on this side. We have another beam on this side. We have another beam on this side. And we have columns at this location, at this location, at this location, and this location. So, if you are standing here, probably your load will go to this direction. So you will find a support here, beam and beam. Probably your load will be moved this direction and this direction because you will find beam here and the beam here. However, your load will not move in this direction and this direction. Why? Because the longer span, which is L, divide shorter span, whatever the symbol B, is greater than or equal to. However, you have 4 beams. So if you have plan of slab between 4 columns, four beams, please check the longer divide shorter. If it's greater than 2 or equal, greater than or equal to, it's one way slab. Which way? Shorter way. Your load will move in the shorter direction. And the longer direction, no, we don't have any load will move in this longer direction. Or I don't care about longer and the shorter ratio if you have only one support in this side and another support on the other side. So no way for your load. We have only one direction, one way. Any questions so far? Any questions so far? It looks good. I think this information are not new, I believe. Okay. The second type of support, which is called two-way support, two-way slab. Two-way means we have beam here and another beam and the third beam and the fourth beam. We have 4. We must have 4 beams around the slab. And the longer to shorter span is less than 2. So longer divide shorter smaller than 2. That means if you are standing here, your load will move in this direction to be supported by this beam, and this direction to be supported by this beam and this beam. Guys, you should know, I believe, the sequence for this structure is, if you are standing on this floor, your load as a live load is supported by slab. Everything on the slab, including the own weight of the slab, is supported by beams. These beams is supported by columns. These columns are supported by foundation. So you need to understand this sequence. I believe you understand them. So slabs supported by beams, beams supported by columns, columns supported by foundation. We have 2 types of slab. One-way slab, two-way slab. The main difference between both of them, the ratio between longer and shorter. Longer divide shorter in one way, greater than or equal. In two-way, less than 2. I'm gonna start with one-way slab. Most of the time, this type of slab exists in bridge, garage, this kind of building. We can expect heavy live load. Heavy live load, we can expect one-way slab. But in office building, hospital, probably hospitals also one-way slab. But office building, residential building, the typical building, two-way. Anyway, so one-way slab, we need first to understand how can I assume the thickness of the slab. Is it 4 inch, 5 inch, 6, 7, 8, 9, 2? So what is the thickness of the slab? ACI give you recommendation. You cannot go below this recommendation, but you can go higher. If you have a slab simply supported like this one, only one slab between only 2 support, that means your thickness probably the span divide 20. So let's assume your span equal 4 feet. Span means the distance between this support and this support, center to center. That means your expected thickness of this slab will be this span 4, please multiply it by 12 to be an inch. Divide 20. That means your expected thickness 4 times 12 divide 20 equal 2.4. Please don't go below the thickness. So I'm gonna assume it 4 inch. I'm gonna assume it 4 inch or 3 inch probably. Why not? If your slab is one end continuous from one end only, span divide 24. Both ends continuous, span divide 28. Cantilever slab, probably cantilever like balcony or patio or something like this. So span divide 10. So this table from ACI 318 for 2018 can give you a guide to figure out the thickness of the slab. Okay, just to remind you, anybody can tell me what are the loads on the slab? Go around, watch around you, your floor. If you assume your floor from concrete slab, made from concrete, so we have on weight of the slab. Do you remember how can we calculate the on weight of the slab? Yeah, H time gamma concrete. I mean here H slab thickness. Don't forget to divide it by 12 to be in feet, because gamma concrete is 150 pound per cubic feet. So your units will be consistent. This is the first weight, and this on weight can be considered dead load. Over the slab, we have something called superimposed dead load. Finishing, covering, anything, sealing, all of this stuff, air condition, all of this stuff can be called superimposed dead load. And this one can be considered dead load also. Then we have life load. Life load for any slab based on the function of this building. And we have a table, we have a PDF file including table, can give you what is the value of life load based on what is the function of the building. So guys, finally, I can figure out what is the final value for dead load, what is the final value for life load, and I can figure out what is the ultimate load, which is 1.2 dead load plus 1.6 life load on slab. I think we are good because we covered all of this information before. But we need to talk about slab, not beam. Do you remember? Slab. Okay, we have a slab between this support and this support with this lens. So guys, I'm gonna assume one strip because your slab is extended in this direction, this direction. So I'm gonna assume one strip. Can you watch this strip? Strip only, one strip from the slab with width equal unit, 1 feet or 12 inch. And assume this strip looks like beam. Why not? We have a beam with cross section. Which cross section? This cross section. Here you go. We have cross section like this. This width 12 inch. This overall depth, which is thickness. That's right. And this beam is supported from this side and this side. So your beam looks like simply supported beam with length L. So guys, it's a slab. Yeah, I know. And this slab is continuous. Yeah, I know. But I assumed I take only one strip. This strip with width equal unit. Width 1 feet. That means the cross section for this strip looks like this cross section. We have uniform load here. This uniform load is W ultimate. Which W ultimate? This one. This one. Without anything? No, without anything, because you need to multiply this one by this width. What is the width here? Is 1 feet. So if you multiply W ultimate from this from this these calculations time 1, which is the width of the strip, it will be the same value. So we have a beam with uniformly distributed, and this beam is simply supported. Your moment will be parabola W L square divide 8. If you are able to figure out the value of moment, you are done with your design. M ultimate divide phi B D square. What is the value? Once you get this value, I can figure out rho, which equal area steel divide B times D. From this relationship, I can figure out the required area steel bare foot, because all of these calculations based on one strip with unit width. Okay, if this width or if this unit width need this area steel, so the next width will need the same area steel. The next width will need the same area steel. The next width will need the same area steel. So I am done. I designed my slab. Because designing of a slab means we need to figure out how much steel reinforcement required in the main direction. One of you will ask me, hey, Dr. Ayman, what will happen if this slab is continuous to this side also and we have many supports? We have another wall, we have another wall. Okay, we covered all of this before. If you have slab, oh, we covered it with beam, the same concept. If you have a slab with 2 span only, your moment here, negative, 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 positive, positive. W L square divide 24, I'm sorry, 14, W L square divide 14, W L square divide 24, W L square divide 9, W L square divide 24. If your slab continues for more than 2, 3, or 4, or 5, okay, we have negative, we have negative, we have negative, we have positive, we have positive. This one, WL square divide 24, WL square divide 14, W square divide 10, square divide 11, W square divide 11, WL square divide 16, 16, and so on. So it's very easy because I'm talking. It's very easy because I'm talking about one-way slab. One-way slab. We need to figure out what is the thickness. We need to figure out what are the weights on this slab. We need to take one strip with unit width. This strip looks like beam. Probably this beam is simply supported if you have only two supports only, or two span if you have only three supports or more. Based on the condition, I can figure out the bending moment diagram. Once you calculate your moment, your design is very easy. Find this term, go to table based on F prime C and F yield. Based on this table, I can figure out rho. Your rho equal area steel divide BD, so I can figure out this area steel, and remember this area steel per unit width of the slab. Any question? We will go through this example right now, but until this point, do you have any question? One-way slab is a piece of cake because you already have a good background about design. Okay. After you are done with your area steel, we need to check we have special area steel minimum. Your area steel minimum equal based on what is the type of steel you are using. If F yield equal 60,000 or greater, your minimum will be greater of this value or this value. Anybody can tell me what is the meaning of area gross here? Area gross means gross area of the slab strip. You remember? We have a strip with unit width, which is 12 inch, and the whole or the overall depth, which is h. If you multiply this term by this term, this area can be called area gross. We have another area? Yeah, probably here is a cross section of the strip. After you put your reinforcement in this unit width, so that means we have something here called depth. So if you multiply depth by unit width, it will not be the area gross. But he is talking about area gross means the whole thickness times the width, the whole area can be called area gross. So when you are figuring out the minimum area steel required according to ACI, please, we are using the area gross, the whole cross-section area. If you are using a steel reinforcement with 50,000 F yield, for example, that means your area steel minimum will be this one. Guys, I have question. I have question. For this one-way slab, anybody can tell me what is the direction of the main steel reinforcement? Your main steel reinforcement that you calculated from here. You already, from your design, you calculated area steel. Anybody can tell me this area steel or this steel reinforcement will be placed in this direction or this direction or both of them? My question one more time. You designed the slab and you finally you figured out how much steel reinforcement required. By the way, your area steel, for example, equal 5 inches square. So I can figure out this 5 equal how many bars and what is the size of the bar. This number and this side will be every 1 feet because you are talking about unit strip. My question is, this steel reinforcement will be placed in this direction or this direction or both of them? Your answer is correct, but wrong at the same time. What you designed will be placed in the main direction you considered. What you designed will be replaced in this direction. One more time, if you are standing here, the direction of your load will be moved in this direction and this direction. Direction of load is the same direction of the main steel reinforcement. Keep it in your mind. If you can figure out the direction of the load, your load will move in this way. This way will be your main steel reinforcement direction. Okay, that means we have only one direction reinforcement. I believe for any slab we have mesh. Yeah, you are right also. We have steel reinforcement in the other direction. But this one is nothing. This one cannot support anything. But we cannot neglect it. We have to put steel reinforcement on the other direction. But we will put area steel minimum. This one, from design point of view, is nothing. This one just for construction, just to construct mesh, steel reinforcement mesh, like this. In one-way slab, one direction only is the main area steel main reinforcement from design, from your calculation. But the other direction is minimum. Minimum. Based on this table. This one. So guys, just keep it in your mind. For one-way slab, we have only one direction. One way. One direction. Which is main. Can you go back to this one? One more time. Can you watch? This direction we have intensive reinforcement. The spacing between reinforcement is very small. It's not very small, but smaller than the spacing between these reinforcement. Why? Because this direction is the main direction. You can expect more reinforcement. But the other direction is minimum. We cannot expect any load. So, but we have to put reinforcement. So this direction will be area steel minimum, but this direction is the area steel from your design. Got it? That makes sense. In a two-way, it's a different scenario. Two-way, we have different. We have in this way and this way and many things. Column strip, field strip. We have many things. We will cover it next meeting. Okay, let's start to do this example. Guys, you are more professional right now. You have more experience. Anything missing in any problem, you can assume. Life load not given, you can assume the function of the building. You can go to the table to figure out how much life load. If prime C is not given, you can assume it 3,000, 4,000, 5,000. If yield is not given, you can assume it 50,000, 60,000. So you have more information right now about all of this stuff. Anyway, we have floor system consists of reinforced concrete slab built monolithically with concrete beams. This beams is spaced 8 feet. The beam span 20 feet. F prime C is given. Okay, I'm sorry. We need to change F prime C to be 4,000, not 4,500, to be more easy, to be able to use tables. Because 4,500, it's not included in the table. Anyway, the surface load on the slab are superimposed dead load, given. Life load is given. Okay, that's fine. I don't need to use any table because life load is given. Okay. We need to figure out the flexion reinforcement required for this slab. Guys, what do you think? What will be the first step? Any answer? What will be the first step in this problem? What do you think? Probably you will not answer this question because we didn't cover the other type of slab. But first thing you need to do, check, is it one-way slab or two-way slab? In your exam, yeah, in your exam, you have a problem with the slab and we need to design it. Okay, is it one-way or two-way? Because two-way is a different scenario, different story. So first step, where is the bay or the span or the rectangle of one slab? This one. This one. Okay, can you tell me this one is one way or two way? We need to check. Longer divide shorter. What is the longer distance? Span 20. What is the shorter? 8. What is the value? I think 2 something, 2.5. Greater than 2? Yeah, one way slab. First step. Second step. By the way, anybody can tell me where is the main direction that I expect to put my main steel reinforcement? Yeah, main direction will be in the shorter direction. That means if you are sitting here, your load will go to this side and this side, shorter direction. So I'm gonna expect to take strip with unit width 1 feet in this direction. Anyway, okay, let's start to figure out the loading. Oh, before loading, because loading will include on weight of a slab. Do you have the thickness of this slab? No, we need to check to figure out thickness of this slab before loading. And we have to figure out what is the type of slab, one way, because based on one way, I can figure out the thickness using this table. We have simply supported. I believe your slab is not simply supported. Yeah, we have many supports here, here, here. So we have many. We don't have continuous from one side. Actually, we have continuous from both sides. So this one will be more realistic. Span divide 28. Your thickness, span divide 28. Continuous from both sides means this one is continuous from here and here. Your span is 8 feet. 8 times 12 divide 28. So probably 3.42 inch. Your number must be integer number. So 4 inch would be good. But don't be more critical. Be more generous. 3.4, I will assume it 5 inch. 4 is good. I didn't say anything. I'm sorry. 3.5 is good also. I cannot say anything. But I don't like to assume a number. And after I did all of my calculations, I found, oh my goodness, I hope to increase it a little bit to make it more easy to be able to find the number in a table. You know what I mean? So from start, be more generous. 3.42, okay. 3.5 is good. 4 is good. 4.5 is good. 5 is good. So I'm gonna assume it 5. I'm gonna assume it 5. Yes, but to be more realistic, Alex, in the short direction, the direction of the main reinforcement or your strip in the short direction. Okay. Next step in the solution of this problem, loading. Guys, we have three loads on this slab. First one, on weight, equal thickness 5 inch, divide 12 to be in feet, time 150. Second load, which called sober embossed dead load, I think it's given. How much? 40 pound per square feet. Life load is given. You are lucky. So we don't need to open the table to figure out the life load. It's given 85. So we need to figure out the own weight. It will be 5 divided 12 times 150 equals 62.5. So guys, we need to figure out W ultimate, which equal 1.2 dead load plus 1.6 life load. 1.2 dead load. Guys, don't forget, this one is dead load. This one is dead load. So I need to put 62.5 plus 40 and 1.6 time life load 85. Your final answer will be 259 pound per square foot. That make easy. Then I'm gonna assume one strip with unit width. So can you tell me, if you take a strip in this slab, your strip will be simply supported? Will be two span only? Or I don't know, it's continuous. So I believe it's continuous because this one is extended in this way and extended on the other way. So we have a span supported here, here, here. So I believe we have negative moment, like this, and positive. How much? W L square divide 16, W L square divide 16, W L square divide 11, W L square divide 11, W L square divide 11. So I forget anything at the beginning, at the end. So can you tell me what is the value of your moment? 259 time L. What is the span? 8? Should be 8. Yeah, 8. Span from here to here is 8. 8 feet, 8 feet, 8 feet. So I can figure out the value of this moment. WL square phi 64 divided 16. This value is 1,336 pound foot. This value will be 1,506 pound foot. Any questions so far? Guys, do you have any questions so far? Okay, looks good. Just to remind you for something which is fatal for me. I don't like to see any of you doing this fatal mistake. Here is the slab, and here is the beams. That's right. As given here. We have a steel reinforcement at the top. We have a steel reinforcement at the bottom. Do you remember how can we figure out where we can put steel reinforcement? Do you remember something like this? Here is the center line of the slab. Okay. Between this support and this support, your bending moment at the top. So compression at the top, tension at the bottom. So we can expect steel reinforcement here at the top, at the bottom, at the bottom, at the bottom. At support, your bending moment below the beam, that means compression. At bottom, that means tension at the top. So we have tension here, we have tension here, we have tension here. Do you agree? Yeah, thank you. Thank you. Your answer, Oliver, is very, very good. Excellent. Wherever the tension. Once you found the tension side, put your steel reinforcement. If you didn't, failure will happen. Tension. Look to tension. Bending moment is drawn on the compression side. That means the other side will be the tension side. Based on this number, okay, let's try first one. This number, 1,036. M ultimate divide phi b d square equal 1,036. This one in pound foot. So I'm gonna multiply it by 12 only. Phi 0.9. B, what is the width of your strip? 12 inch, 1 feet. What is the depth? Hey, don't say 5 inch. Guys, 5 inch is the overall thickness, but I'm talking about depth. So I'm gonna assume 1.5 inch cover. Then the depth will be 5 minus 1.5. It will be 3.5 inch. Do you remember in the beam? Do you remember beams? I'm gonna assume this one 2.5. In slab, it will be smaller. Here is the steel reinforcement. So this one will be 1.5. So the remaining distance will be depth. So this is the slab. This is the beam. So your depth is 3.5. Square. Don't forget square. Your answer will be 93.8. 97. I'm gonna open my table because I have something here very interesting to you guys. What is the value of f prime c? 4,000, 60,000. Okay, 4,000. 40,000, 50,000, 60,000, and 4,000. Yeah, here you go. This one and this one. What is the value of rho? I'm sorry, what is the value of this expression? 93. Where is 93? Okay, so it looks like very, very, very small. So I'm gonna assume we are here. So your rho will be 0.0018. We don't have any values smaller than 106, and your value is 93. So I'm gonna use this one, 0.0018. So your rho equal 0.0018. This value equal area steel divide B times D. So equal area steel, your B is 12, 1 unit, your width, D 3.5 inch. So I can figure out the value of area steel. This value will be 0.0018 times 12 times 3.5 equal 0.0756 inch square per foot. Why per foot? Because you are talking about one strip with unit width. We need to check area steel minimum. That's right. We need to check area steel minimum. Go back to this table. Are you here or here? I believe your steel reinforcement with F yield 60,000. So we are here. So I'm gonna use this expression or this expression. Which one is greater? Let's start the first one. 0.0018 times 60,000 divide 60,000. Oh my goodness. It will be 0.0018. This one is 0.0014. Which one is bigger? This one. So the area steel minimum, you are lucky, equal 0.0018 area gross. One of you will say, hey, it's the same value. No, it's not the same value. This 1.0018 times area gross, which is 12-inch width, times the whole thickness, 5-inch. But for this one, rho equal area steel divide B times depth. This one from a table. So I can figure out this area steel. For area steel minimum, okay, I got this value. That's fine. But multiplied by area gross. So your area steel minimum will be 0.108 inch square per foot. Do you think I'm gonna use the design value or the minimum value? Which one is bigger? So I'm gonna use area steel equal 0.108 inch square per foot. Any question for this point? Guys, just to remind you, this table using area gross, which is the overall depth time width of the strip. But based on your calculations, M ultimate divide phi BD square will give you a value for rho from a table. This value of rho equal area steel divide B times depth. and I can get the area steel, and I can get the area steel minimum, I will use the maximum value. Any question? Okay. I would like to convert this value of area steel to how many bars and what is the size of this bar and this reinforcement per foot. That's right? That's right? Guys, can you look to this table? Which one? This one? Yeah. Table A6. Area of bars in slab per foot. Can you remind me what is the area steel? 0.108. I think probably you are here. That's right. 0.108. So we don't have this number, but probably 0.11 will be good. That's right. Okay, you are done. What you mean by you are done? I'm gonna use bar number 3 every 12 inch. So every 12 inch, I have to put a bar number 3 in this slab. So here is the number, the size of the bar. Here is the spacing between these bars. Here is the area steel per foot. So based on the area steel per foot, you got it? I will select my number, and this number will tell you what is the size and what is the spacing between bars. Guys, the final answer to design a slab, I need to figure out what is the spacing between this bar and this bar. What is the spacing? What is the spacing? And what is the size? This table can help you to do so. Table A6, area of bars in slab, can tell you what is the size, what is the spacing, based on what is the area steel you need. So in our case, 0.108. We don't have this number, so I'm gonna assume it 0.11. One student will ask me, hey, okay, if I assumed it 0.13 and I'm gonna use number 3 every 10 inch, you are right. You are more safe. You are more safe. You have more money. So you to spend for this material. You are good. But this one will be enough. More than this one will be good also, but cost will be higher. You know what I mean?
Dr. Amen?
Yes.
So what we found, the number 3 rebar over 12 inch. I know earlier we said that's the minimum, but isn't it actually that's the maximum spacing, or is that the minimum spacing?
This is the maximum spacing.
Okay, maximum spacing. So I can't do.
You cannot go more than this 12 inch and the number 3. This is the minimum bar size. This is the maximum spacing.
Okay.
Yeah, that's happen all the time. Most of the time, for one-way slab, your load is not higher enough, so we can expect minimum. But if you have more live load, if you have more superimposed load, if you have bigger spans, probably this span is 10 or 12 or 15. so you can expect more moment, so you can expect more reinforcement. But this table, keep it in your mind in designing a slab. If you are designing a slab, we are going to use this table. Also, if you are designing footing, actually, if you are designing any structure and your reinforcement is putting with spacing. For beam, no, we don't care about spacing. We need number, how many bars. But if you are talking about spacing, what is the spacing between bars, like footing, slab, raft, all of this stuff, we will use this table all the time. Any question, guys? Yeah, go ahead, Alex. What I did, this reinforcement, which is number 3 at 12 inch for moment 1036, which is here. So your reinforcement is number 3 at 12, number 3 at 12, number 3 at 12 inch, number 3 at 12 inch. Why? Moment here, the same like here, the same like here, the same like here. We need to repeat all of this stuff one more time for the moment at supports, which is 1506. This value can tell you how much is the reinforcement here and here and here. Like we did with beams. Do you remember? So we need to calculate one more time. M ultimate 1506 divide phi BD square and define another row and define another area steel and check it with area steel minimum to figure out which one I'm gonna use, and then go to the table to figure out what is the size and what is the spacing. This steel reinforcement will be at this location, at this location, and this location at the same location of the moment. Okay, Alex?